Have you ever wondered how large construction projects are planned and executed so efficiently? This is where network models come into play. They are an integral part of the construction industry, serving as the backbone of planning and scheduling. Network models help carve out the complex process of construction into discrete, readily definable activities. Each activity in the network is assigned a fixed duration, determined by resource availability and physical conditions. This deterministic approach ensures a streamlined planning process, allowing for effective scheduling and monitoring of the project. Moreover, the logic of the network represents the planned sequence of work, leaving no room for confusion. It ensures a unidirectional flow of activities, from the start of the project to its completion, with no iterative loops. In essence, network models provide a robust and systematic approach to managing construction projects, making them indispensable tools in the industry. So, let's delve into the fascinating world of network models in the construction industry. One of the primary characteristics of network models is the concept of discrete activities. In the realm of network models, discrete activities are the building blocks. They represent distinct, easily identifiable parts of a construction project that need to be planned, monitored, and controlled. To put it in simpler terms, imagine building a house. Each task, from laying the foundation, raising the walls, to installing the roof, represents a discrete activity. Each of these tasks is clearly defined and separate from the others, yet they all contribute to the completion of the house. Now you may wonder, why is this important? Well, discrete activities serve two main purposes. First, they help in scheduling. By breaking down the project into smaller, manageable tasks, it becomes easier to plan when and how each activity should be carried out. This not only ensures a smoother workflow, but also makes it possible to assign resources efficiently. Second, discrete activities play a crucial role in monitoring and controlling the project during construction. By keeping track of the progress of each activity, it becomes easier to spot any delays or problems early on. This allows for quick adjustments and helps to keep the project on track. It's like having a roadmap that guides you towards the successful completion of your project. Let's not forget, discrete activities are not just about the tasks at hand. They also include considerations for resource availability and physical conditions on the site. For instance, the activity of pouring concrete for the foundation would take into account the amount of concrete available, the weather conditions, and the readiness of the site. In essence, discrete activities are all about breaking down a complex project into smaller, manageable parts. They provide a clear picture of what needs to be done, when it needs to be done, and how it should be done. This clarity and structure are what make discrete activities an essential feature of network models in construction. Thus, discrete activities form the backbone of any network model in construction. Another critical aspect of network models is deterministic durations. When we talk about deterministic durations, we're referring to the fixed durations assigned to each activity in the network during the planning process. These durations are not whimsical guesses or rough estimates. Instead, they are carefully determined based on two key factors: resource availability and physical conditions. Imagine you're building a house. You have a team of 5 skilled workers, and you know from past experience that it takes roughly 2 weeks to lay the foundation. That's your resource availability. Now, if the weather forecast predicts 2 weeks of sunshine, that's your physical condition. Put these two together, and you have a deterministic duration. But what if it's not as straightforward? What if you're dealing with a massive construction project with hundreds of activities? That's where the beauty of deterministic durations comes in. Each activity, no matter how small or large, is given a fixed duration. This duration becomes the basis for scheduling and monitoring the project. It's like a roadmap, guiding you through the maze of activities and helping you keep track of progress. Now you might be wondering, what about unexpected delays or changes in conditions? Well, deterministic durations aren't rigid or unchangeable. They are, however, the planned durations based on the information available at the time of planning. If conditions change or unexpected issues arise, these durations can be reassessed and adjusted as needed. But let's not forget the main purpose of deterministic durations. They are not just about scheduling activities, they are about ensuring the project stays on track. By assigning fixed durations to each activity, you can monitor progress, identify potential delays, and make necessary adjustments to keep the project within the planned timeline. So, while it might seem like a simple concept, deterministic durations are actually a powerful tool in the world of construction. They provide a clear framework for planning, scheduling, and monitoring, making it easier to manage complex projects and ensure successful completion. Deterministic durations are instrumental in keeping the project on track and within the planned timeline. Deterministic logic is another vital characteristic of network models. It's like the backbone of the project, giving structure to the sequence of work. But what exactly does it mean? Well, deterministic logic refers to the fixed sequence of activities in a project. It's like a roadmap, charting out the path from the start of the project to its completion. It's decided during the planning phase based on the nature of the project, the resources available, and the physical conditions. Once it's set, it remains unaltered throughout the project's lifespan. This doesn't mean that the sequence is rigid or inflexible. It's more like a guide, a framework that provides direction and order. It ensures that all the tasks are carried out in the right order, and no steps are skipped or repeated unnecessarily. It's like a well-rehearsed dance routine where every move follows the previous one in a predetermined sequence. Now you might ask, why is deterministic logic so important? Why can't we change the sequence of activities as we go along? Well, imagine you're building a house. You wouldn't start with the roof before laying the foundation, would you? Each step in the process has its place and time. Changing the sequence could lead to complications, delays, and even failure. The key point here is that deterministic logic doesn't allow for conditional or probabilistic network branching. This means that the sequence of activities doesn't depend on any conditions or probabilities. There are no if this then that scenarios. Everything is planned and fixed from the start. There's no room for guesswork or uncertainties. This might seem restrictive, but it actually ensures the smooth flow of activities. It reduces the risk of errors and delays, and helps keep the project on track. It's like having a reliable GPS for your project, guiding you from start to finish without any detours or roadblocks. Deterministic logic ensures the smooth flow of activities as per the planned sequence. It's the secret ingredient that helps transform a chaotic pile of tasks into a well-organized, efficient project. The last but not the least characteristic of network models is the activity flow. Now let's dive into what it means and why it's so essential in managing construction projects. Activity flow in network models refers to the progression of tasks or activities within a project. It's a bit like following a roadmap, where each point on the map represents a discrete activity in the project. You travel from one point to another, always moving forward until you reach your destination. That is, the completion of the project. In other words, activity flow is unidirectional, starting from the inception of the project, going through each planned activity in order, and culminating in the project's completion. This one-directional flow ensures that every task is executed as per the planned sequence, maintaining the project's momentum and helping to avoid delays. You might wonder, why can't we loop back to previous activities? Why is it so important that the flow of activities is unidirectional? Here's why. In construction projects, revisiting completed tasks can lead to unnecessary delays, cost overruns, and even potential conflicts. Once an activity is done, it's done. Going back is not just inefficient, it disrupts the entire workflow. To illustrate, imagine building a house. You wouldn't install the roof before laying the foundation, right? And once the foundation is laid, you wouldn't dig it up to start over. Each step follows the previous one in a logical, unidirectional sequence. That's the essence of activity flow. It's worth noting that while activity flow is deterministic, meaning it's predetermined and fixed during the planning stage, it doesn't mean it's inflexible. Adjustments can certainly be made as needed, but always in a forward direction, keeping the end goal in sight. In conclusion, activity flow in network models is like a compass guiding the project's journey. It ensures that the project progresses smoothly from start to finish without any hiccups. It's an indispensable tool in the efficient and effective management of construction projects. Let's summarize what we have learned about network models in the construction industry. We've delved into the details of discrete activities, which are readily definable portions of a project, scheduled, monitored, and controlled throughout the construction process. We've also discovered deterministic durations, where each activity is assigned a fixed duration based on resource availability and physical conditions, aiding in efficient scheduling and project monitoring. We then explored deterministic logic, the planned sequence of work that is fixed when the activity network is developed, without allowing for conditional or probabilistic network branching. Lastly, we discussed activity flow, which is unidirectional from the start to the completion of the project, prohibiting iterative loops of activities. While there are other models that permit probabilistic durations, conditional logic, and iterative activity loops, Understanding the characteristics of these network models can significantly enhance the efficiency and success of any construction project.